Okay, in this video we will learn about set. Okay, set. So here a set is a collection of well-defined objects. We know set is a collection of well-defined object. Example, n is equal to 1, 2, 3. Set of all natural numbers 1, 2, 3, etc. W is equal to 0, 1, 2, 3 whole numbers. Okay, well-defined means for example, it should be like set of all, it should be defined well. Set of all students who got more than 50% marks in the final examination. So it is defined well. So we call that set to be well defined. If I say set of all beautiful girls in the class or handsome boys in the class, so that is not well defined, right? It is not well defined. We cannot select people using that definition. So set is always a collection of well defined objects. So I think these things are familiar to you. So I can just read the definition so that you can take down. Finite set, a set which have finite number of elements. Null set, a set having no elements denoted by 5. So these are familiar to you, right? Singleton set, set having single element, exactly 1. Equal set, two sets A and B are said to be equal if and only if every element of A is an element of B. So both A and B have same element, then they are equal set. Universal set, A is said to be universal if it include every set under discussion. Universal means that is a main set. So all other set are subset of this universal set. That means it includes every other set. Subset, a set A and B be any two set of every element. Let A and B be any two set if every element of A is also one element of B, then A is subset of B denoted by this symbol. Okay, subset, you know, actually like C. Okay, this is a C which it is here. Okay, this is called a subset. A is 1, 2. You see 1 is element of B, 2 is element of B. So A is subset of B. Then number of subset. If a set contains n elements, number of subset is equal to 2 raised to n. If for example A is 1, 2, 3, then 2 power 3, 8 is the number of, it has 8 subsets. You see subset 1, this is a subset, 2 is a subset, 3 is a subset, 1, 2 is a subset, 1, 3 is a subset, 2, 3, 1, 2, 3, then empty set. Totally we have 8 subset here. Then superset, a set A is subset of B, then B is called superset of A. You know, the larger set is called superset. So even here A contained in B, B is called superset, A is called a subset. So that's the definition for superset. Then power set, let A be a non-empty set, then the set of all subset of A, let A be a non-empty set, then the set of all subset of A is called power set of A. This is denoted by P of A. What is P of A? P of A is set of all subset. So that means this set is called as power set. Means it contains all the subset of A. So power set is then A is a non-empty subset of A. Then the set of all subset of A is called power set. Let us learn some operations on set. Union, this we are familiar with this. Union of two set A and B is defined like this. A union B is set of all x such that x belong to A or is here. Okay, either x belong to A or x belong to B. Then intersection of two set A and B. Then all the elements in, that means the elements that belongs to A and B. Okay, the set of all elements in A and is here. You see A intersection B is x, you read it as such that, okay, this line is such that x element of A and x element of B. Then complement, let A be any set and union be U be universal set. The complement of A is set of all elements on it but not in A. What do you mean by complement? You have to consider the bigger set, that is the universal set. Set of all elements in the universal set that should not be in A. That is called as A complement. And it is denoted by A power C or A dash or A bar. A bar is set of all x such that x belong to unions. This is capital U, make it as capital U. And x does not belong to, you can write it as does not belong to E, then you can put a slash mark, okay. Does not belong to A. For example, U is equal to 1, 2, 3, 4 up to 10. A is 2, 4, 6, 8. What is A complement? A bar stands for A complement. That means you have to write all the elements in U except this 2, 4, 6, 8. Except 2, 4, 6, 8, we get 1, 3, 5, 7, 9, 10. That is complement. Set of all elements in the universal set, but that is not in A is called as A complement. Set difference. Let A and B be the two sets. The difference of A and B is set of all elements in which set of all elements which belong to A but does not belong to B, denoted by A minus B. Belong A minus B means you are subtracting B from A. That means that belongs to A but that does not belong to A. B, okay, that belongs to A but does not belongs to B. You see, set of all x such that x belongs to A and x does not belong to B. Example is here A, B, two sets 1, 2, 3, 4, 3, 4, 5, 6. A minus B. From A you subtract B, that is 3, 4, 5, 6. 3, 4. So what remains? 1, 2. 1, 2. Then B minus A. From B you subtract A. 1, 2, 3, 4. 3, 4. 5, 6 is the answer. Then properties of set operation. Let A, B and C be any three set. We'll learn some properties which are familiar to you. A, B and C be any three sets. Associative law A union B union C is A union B union C. Commutative law A union B equal to B union A. A intersection B is equal to B intersection A. Distributive law A union B intersection C is equal to A union B intersection A union C. A intersection B union C is equal to A intersection B union A intersection C. Identity law A union empty set is A intersection empty set is empty set. A intersection universal set is A intersection universal A union, okay, make it as union. This is union, you can make it as U. A union of universal set is universal set U, okay, that is the larger set. Then identity law A bar the whole bar, that is this is involution law, okay. A bar the 2 bar, double bar is here. A bar the whole bar is A. Then A union B the whole bar is A bar intersection B bar, okay. A bar intersection B bar. A intersection B the whole bar is A bar union B bar. So this is De Morgan's law. You can write it here, okay. That is De Morgan's, D-E-M-O-R-G-A-N, De Morgan laws. Then we come to countable set. A set which is either empty, finite or countably infinite is called countable set. So countable set means it is either empty set is also called as countable set, finite set is also called as countable set, or countably infinite set is also called as countable set. Countable infinite set, what is that? You see, countable infinite set is countable infinite if and only if there is one-to-one correspondence from natural number to set A. So natural number means you can take 1, 2, 3, 4, 5, 6, etc. It goes on. It is infinite, right? So we say it is countably infinite. Also, we can map it to the set A. 1 is mapped to the first element, 2 is mapped to the second element, 3 is mapped to the second element. Likewise, it can go up to infinity to any number, that is called as countably infinite or denumerable. Okay. Natural, so that is one correspondence from n. Natural number to set A. Then Venn diagram. So Venn diagram means you would have learned this earlier. It is the pictorial representation of a set. The universal set U is represented by the interior of a rectangle. So it is here. So universal set is represented by interior of a rectangle. Universal set, yeah, subset are represented by circle within the rectangle. So universal set is a rectangle, subset are inside that like a circle, represented by circle. Let A be any set. The Venn diagram represented by its complement is the shaded region. So you see, for this is universal set. What is A complement? So inside that we write A. A complement means except A you have to shade the remaining portion. Universal minus A. Okay, this is A complement. So this is A bar. Then union of A and B. So you see, this is U. This is B minus A. Okay, this is actually, this is A intersection B bar, or you make it as A union B. Okay, A union B, and you can shade this portion also. You can shade both A and B. You can shade this intersection area, and that is A union B. Mark it as A union B here. B minus A, from B we subtract A. Okay, from B we subtract A. A intersection B, that is common region. A minus B, from A we subtract B. That is the representation of Venn diagram. Cardinal number of a finite set A is the number of different elements in that set. Cardinal number of a finite set A is the number of different elements in that set. So here 1, 2, 3, 4, 5, 7. Okay. N of A. Cardinal number of the finite set A is the number of different elements. So number of different elements means 1, 2. So A contains, so you can take an example like this. Okay, you can take an example like this. A is equal to 1, 2, 3, 4, 5. So cardinal number of a finite set is the number of different elements. So N of A is equal to, what is N of A then? Number of different elements, 1, 2, 3, 4, 5 elements are there. So N of A is 5. So that is the cardinality of the given set. Okay.